Okay, we're looking at section 6 now. We're getting into what's known as the sine ratio and the cosine ratio. So I'm going to show you a quick way to remember sine, cosine, and tangent. We call it SOHCAHTOA. So we have SOHCAHTOA. And the reason for this is we know that the sine of an angle, we'll call it R, is equal to opposite over hypotenuse. We know cosine of R, where R is the angle, would be adjacent over hypotenuse. And as you've learned from the last section, tangent of R is equal to opposite over adjacent. So this gives you a quick way to remember all three of those. If you look carefully, you can see that sine is opposite over hypotenuse, hence the SO there. Cosine is equal to adjacent over hypotenuse. There's the ka. And for tangent, that's opposite over adjacent. So we have our SOHCAHTOA. Okay? Alright, so we're going to use sine this time, so we're going to do opposite over hypotenuse. And if I'm doing sine of S, that's going to be equal to, again, opposite over hypotenuse. Opposite angle S is this side right here, so that's 63. And then the hypotenuse is 65. Since this can't be reduced, we would just keep it as is, and then we want to do a decimal rounded to 4 decimal places. When we do sines of angles, we're going to do it to the nearest 10,000th or 4 decimal places. When we do it for the angles, we'll either do it to the nearest tenth or we'll do it to the nearest whole degree. So 63 divided by 65 is 0.9692 if we round. Okay? Now we want to do sine of R. And again, this is just a relationship between sides, and what we'll find out in a bit is, actually I think in the next section, is that this is very closely related to the actual angles. We can use this ratio to find out what the angle is. So directly opposite R is 16, and we divide that by 65. Again, that can't be reduced, so we just find the decimal equivalent. 16 divided by 65 gives us 0.246, and if we round, it's 2. Okay? So that's all they want you to do in this section. Here's sine of S, again opposite over hypotenuse, 63 over 65, which is 0.9692, and then sine of R, again, is opposite R, which is 16 over 65, which is 0.2462. We're going to do the same thing again. Again, we want to do fraction and decimal to 4 decimal places if necessary. So if it ends up not being 4 decimal places, just write as many as you need. So sine of X, we're doing still opposite over hypotenuse. So there's opposite, hypotenuse is the longest side, opposite the right angle. So this would be 8 over 17. Again, we can't reduce that, so we're going to just do 8 divided by 17, and we get 0.4706, and that is approximate. For sine of Y, again, we're doing opposite over hypotenuse. So here we have 15 over 17, and we're going to punch that into our calculator, and we get 0.882. If we round, it's 4. So 0.8824. There we go. And let's do another one of these. Sine of x is equal to opposite x, which is 15, over hypotenuse, the longest side, 25. This time we can reduce. Both of those are divisible by 5, so this becomes 3/5. And if we divide those two, we get 0.6 for sine of y. Remember, this time we're going opposite y, so that's 20 over 25. That's equal to 4 over 5 if we reduce, and that's equal to 0.8. Okay? And that's it. Thanks.